Well, in this question, we've got to label the sides of each triangle for O for the opposite, A for the adjacent, and H for the hypotenuse with respect to, that means from, so with respect to the reference angle. And here the reference angle, I'll colour the reference angle in yellow. There's the reference angle in that triangle. This is the reference triangle in this reference angle. We're talking about this as being the reference angle, and we're talking about 71 being the reference angle. So for the first question, from the 25 degrees, let's not use that thick line. From the 25 degrees, this is the opposite. I want to go to the adjacent next. The adjacent side is one of the sides which wraps around the 90 degrees. And then finally, the opposite longest side from 90 degrees is called the hypotenuse, and hypotenuse is the longest side of any right angle triangle. So that's what A is. I'd like you to do B, C, and D. And down here, use the given sides to calculate to 2 decimal places. Now, because I've got 2 decimal places, I'm going to highlight this and put a little box, because I've got to tick that box before I finish. Otherwise, we'll forget to do 2 decimal places. And we want for sine, cosine, and tangent of 25. So let's just do sine of 25 degrees equals the opposite over the hypotenuse, 11. What I'll do is I'll just put the opposite over hypotenuse just so that you know which sides we're doing. The opposite side is 11 and the hypotenuse side is 26. You get the calculator. Oh, I'll do that later. Let's do cos of 25 degrees, and cos is the adjacent, so katoa. So I'll put that up here. So katoa, so it helps you remember. The cos is the adjacent, which is 24. The hypotenuse is 26. And tan of 25, which is opposite over adjacent. Tan is opposite over adjacent. The opposite side is 11 and the adjacent side is 24. If you've got the correct opposite side is 11 and the adjacent side is 24, you should not make a mistake. But we're not finished, because the question did say correct 2 decimal places. So in the calculator, I've got to go off line here and just in my calculator go 11 divided by 26. And that's 0.423. So I'm going to put, I'll use black here, approximately 0.42. And that's to 2 decimal places. And for 24 divided by 26, we should get 0.923. So I'm going to stop at 92. That's 2 decimal places. And 11 divided by 24, and we get 0.458. So because we got that 8, we've got to write 0.4, not 0.45, but 0.46. And now we can tick that box because we have answered them to 2 decimal places. So I've done 3A. For 3B, you've got to use this triangle up here, the 62-degree triangle. For 3C, you've got to use the triangle with the 44-degree angle. And for 3D, you've got to use the triangle that has the 71-degree. And they should help you work out sine, cos, and tan for the other 3 angles. You can always look on your calculator. You can always go to your scientific calculator and double check sine of 25. So on my calculator, if I just go sine of 25 on your calculator, you should get 0.422. But that's not how we want you to do it. We don't want you to use your calculator. We want you to use the sides in the triangle. But you should be able to look in your calculator, get cos of 25, just to double check that you're correct. Cos of 25.906 will actually, your calculator give you 0.91. And tan of 25 and 0.466, you'll get 0.47. So you get a slightly different answer if you use a calculator. And just to wrap it up, I want to state something very important that I used before. When you've got sine of 25 degrees is 0.42, if sine of 25 degrees is 0.42, what we're saying is 0.42 as a fraction, as a decimal, as a percentage, 42%. What we're saying is that in every right angle triangle, if there is a 25-degree angle in one of the corners, the opposite side is about 42% of the hypotenuse. And that's what's going to happen if one of the angle is 25. That's always going to happen. For cosine, if you're told that cos 25 degrees is about 0.92, well, it's actually not 0.92, but in this triangle it is. I think we said it was about 0.91. But 0.92 means you've got 92 over 100, 0.92, 92% is another way of saying 0.92. So if cos of 25, it means the adjacent side, if one of the angles is 25, the adjacent side is about 92% of, and it's actually 91% in reality, 92% of the hypotenuse. And if tan of 25 degrees is about 0.46, then what we're saying is, well, 46 over 100, 0.46, 46%. We're saying that the opposite side, because it's tan, right? The opposite side is about 46% of which side? Tan is opposite over adjacent. So we're saying that if tan of 25 is 0.46, that means the opposite side is about 46% of the adjacent. And if you look at the hypotenuse as 26 over here, if you calculate 42% of 26, 0.42% of 26, you get about 11. That's correct. The opposite side is about 11. If you go the second one, cos of 25 is 92% of the hypotenuse. So 92% of 33 of the hypotenuse, which is 26, we get 24. Yes, the adjacent side is about 24. And in tan, 25 is 0.46. If you go 0.46 of the adjacent side, which is 24, you get the opposite side. So the opposite side is about 11. And just for accuracy's sake, just in conclusion, sine of 25 and the calculator is about 0.422. So yeah, that's good. Cos of 25 degrees is actually, cos of 25 degrees is actually on the calculator 0.906. So look, it's actually 0.91, but that's not what we got. I think let's just double check. 11 divided by 24 divided by 26, 24 divided by 26, we got 0.923. Yeah, our question does give us 0.92. And just for accuracy's sake, tan of 25 on the calculator is 0.466. So tan 25 is about 0.466, which is really the 2 decimal places 0.47. So I'll just put up here, just for the benefit of accuracy, it's actually 0.47, but that's using a calculator, all right? So our calculator gives us a slightly different answer than the diagram, but we'll just do that for accuracy's sake so that you're aware. Always check the figures and look for accuracies and analyze questions. It's fine. And anyway, I hope that this has helped. Until we talk again, stay happy.